No problem.
Sure. You want to do I'm usually the guy, so.
We're highly secure, Ed. We have super secret passwords. All right, let's go ahead and get started. This is DTN. Just in honor of where I came from, good morning, everybody.
I can do the. Yeah, I can.
All right, so this is the infamous note well. So note it well. Next, please. Here's our agenda. Just to keep in mind that the main goal here is to figure out the issues that we have and work through 50/50 biz. So much like the last session we had, if things drop off the bottom of the agenda, it's for a good reason, and no ill will is aimed at anybody. The question that I have, is there anything up here that people want to scream about and possibly change? Good, no screaming. No. All right, we have our workgroup secretary. We drug Ed in here. Did you get your password figured out yet? Awesome. Mark will be starting the blue sheets. Please sign those, and if you feel the need, sign the blank check underneath it, and I'll fill it out later. Do I have anybody who's willing to scribe the meeting in addition to Ed, in case he's getting up and basically a backup for Ed in case he decides to get up to the microphone and say something or present something? Thank you. Anybody going to hang out in the Jabber room and willing to at least at a minimum relay questions that might come in from people who are not here? Thanks, Rick. And if you have any questions about this working group or what we're doing, the charter is there, so feel free to go visit. All right. Quick review, milestones. Like I said, the main thing that we want to try and accomplish here is get the 50/50 biz work in a place where we can start pushing that forward. And then once we start working that through, we have the addressing architecture, the security protocols, node neighbor contact discovery protocols, service identifier registries, and potentially the static routing. Right now we have potential work items for the enhanced neighbor discovery and whether or not we're going to investigate key management, but there are no deliverables associated with that. Any questions on that? All right. So I believe that Scott is up.
Yeah. Not sure which one.
So these are the same slides as last time, except for the first 2 pages having been chopped off because we addressed all of those at the August 28th conference call. Ah, right, great. Yeah. Oh,
Yeah, and for those of you who are actually presenting, our infamous pink box is back. So please stay in it if you want to be photogenic for everybody who's remote.
Okay. So we don't have a lot of time, so I think we just start in. If we go to the first slide, that is next slide. Oh yeah. Oh, great. Okay. So I won't go into reviewing all the things that we converged on in the August 28th meeting, and just plunge into the remaining open items from the draft. There was a revised edition of the draft that went out a couple of weeks ago. I've got comments back from Ed that we've talked about. There are comments coming back from Kevin that maybe we'll come across in the conversation today, but anybody else that has thoughts on that draft, please send them on. And in the meantime, let's see if we can crank through some of these things and set them aside so that I can address them in the next edition of the spec. So the first of these is one of these leftover open items. It has been suggested that we divide the bundle protocol spec into two documents. One that is the concept of operations and context and other sort of non-normative content, and the other that is the normative protocol spec. With the removal of the protocol structure diagrams that came out of the decision to accommodate multiple representations of bundles, the bundle protocol spec is now down to about 45 pages. So my thinking is that it's now brief enough and manageable enough that there's not a lot to be gained by splitting into two documents, but I'm open to alternative points of view on this. Anybody have a feeling on it one way or another?
Hi, Rick Taylor. I'm in favor of splitting into two simply to make it easier for the end user of these documents. One, very much reference material in terms of what are you trying to achieve here, and the other one in how do I actually do it. Mm-hmm. I just think it makes it easier to manage and might make it easier to manage as documents for you and any potential author team.
Okay, thanks.
Kevin Fall, CMU. The opposite of what he said. I did make some comments. Unfortunately, they were stuck in my outbox, so now they should be coming out as we speak. But I had a couple of editorial suggestions to reduce it further, particularly the areas where it says an implementation could be a process, or it could be a sensor node, or it could be, if we just trim some of that out, then I think the reading 40-ish pages seemed okay to me.
So to summarize, I think you're in favor of just removing that material altogether rather than splitting it into a different book.
If that material refers to, well, it could be one of those, and it could be one of those, which I read the way it's written as an implementation option. Yeah, I think that could be safely removed from this, period.
Okay.
And if somebody else wants to go write something else, fine, that's okay. But I don't think it belongs there.
Okay.
Rick Taylor again. Following on from what Kevin said, if it does get shorter, then splitting it becomes a bit pointless at that point.
Okay. So does anybody else have any thoughts on the material that Kevin's talking about here? This is the alternative potential implementations. Let me just give some background on that. The intent, I believe, of that material going way back in the mists of time was to open the possibilities of the specification as far as possible to implementers and encourage everyone's imagination. It may be that that's just not necessary, and I'm certainly not wedded to that text. I'm perfectly happy to lose it if we all think it's a text that we don't have to hold on to. Just as a procedural kind of thing, let me just ask the chairs. We're trying to work through these and resolve these open issues. Does it make sense to try to hum or something as we go through them? Do it at the end? Do it afterwards in a follow-up telecon? What's the best approach?
So I really don't see a need to do a hum on each item if there doesn't seem to be any disagreement with what's going on. If somebody jumped up at the microphone and they're a fist fight between the 2 points, then yeah, we'll do a hum. But let's just try and move things as efficiently as we can, and
Okay.
unless there's disagreement. And then what we'll do is after the meeting, we'll actually any point where we need to make a decision, we can do that on the mailing list, and that way people can voice their opposition with the proposed way forward.
Okay, so we won't try to make like firm decisions in this meeting. We'll do them on the mailing list with a summary of the discussions. Yeah?
Yes.
Yeah. Okay.
Yep.
Good. Okay. So if we're not going to try to actually resolve all of these things in the meeting, then I think we should just go on to the next point, unless somebody has something else to say on this first point. Anybody?
Scott, Mark, we want to resolve those things here, but we want to confirm on the mailing list so that people who are not here can say something so we want to resolve those here.
Except that it's not really resolving. It's documenting the sense of the meeting. Yeah.
Okay.
Yeah. It's because it's not a real resolution if it needs to be confirmed, right? It's
Yeah.
a proposed. Yeah. Yeah. Okay. So, all right.
What I'm trying to say is we should take this time, face-to-face time, to try to advance those things to a point where we agree on the way forward, right? That's the whole.
I agree, but if the decision really has to be made on the mailing list rather than here, what we can do here is we can say that the sense of the people who were at the meeting is thus and so.
Yeah, that's
not that this is what we're going to do, and then we can confirm that in a mailing list. So yeah.
We don't necessarily need a hum to do
Yeah.
that.
Yeah. Okay. So I'm gonna suggest that the sense of those of us at the meeting is that the material that Kevin is talking about on possibilities for alternative implementations can safely be removed, and that in doing so we shorten the book enough that we don't need to split it into 2 books. And that's what I'm going to suggest is what we all agree. If anybody strongly disagrees with that, would you speak up? Okay, let's move on to the next one then. This is a really small point of the protocol that came up as something that looked funny during the review about 6 months ago, and that is the spec right now says that that a node can clear the block was forwarded without being processed flag of a bundle, and it gives some conditions under which you can do that. Does anybody have any feelings about whether that is an okay thing to retain, or whether we should remove that capability, that the ability to turn off that flag? Oh, we seem to be getting the same 2 voices.
Rick Taylor again. I think for me, the clue is in the name of the flag.
Mhm.
If you forwarded it and did process it, then you should probably have cleared the flag to say I forwarded it without processing it. And I understand it's clearing the flag that has arrived to you, but if you're processing it, then I can understand the semantics you're trying to capture here, and perhaps that should be covered by some other different flag to say, I processed this, I have just processed this, but somebody else prior to me didn't.
Right.
Does that carry?
It's
Just doing that in one bit seems to be.
It's the scope of that flag that
Yeah.
really is at issue here. It's like, does the flag mean that the most recent handler of it processed it or didn't, or does the flag mean that the entire processing chain up to this point processed it or didn't?
I completely agree. So to answer your immediate question, yes, it should clear it. But actually, I think that question opens a bigger question.
Would you argue for a second flag that would be like the sort of cumulative, somebody at some point didn't process it?
I'm going to have to reread that bit of the spec again. Sorry.
Kevin Falls, you know, the opposite of what he said. My understanding when this was discussed, when we came up with this idea, was that the purpose was to receive something and say, did this option extension pass through a network such that somebody didn't play the game? In which case you would never clear that. But I guess, to be honest, if we don't have totally compelling use cases either way, I'm not sure what to say. But
would you be in favor of removing the flag altogether?
Until we figure out that we really need it.
I mean,
that's a compromise.
Mark occasionally points out that it'd be nice to simplify this spec instead of complicating it all the time. And if this were a little simplification we could do, I'd be fine with that.
John Dowdle, I suggest you might want to either simplify it by removing it or make it more complicated by saying, well, who processed it? Because there might be 3 nodes in the chain that processed it. Is that important? I've no idea.
Right, and so I think that's the key is like we don't really know if it's important. So I'm inclined to go with my thinking right now coming out of this is maybe we should just remove it, and if we really care about it, put it back in as an extension block, and maybe when we do that, we do things like attach a user to it.
Kevin Fall again. Indeed, I mean you could say with maybe some initial option, I want to know everything that happens.
Yeah.
And then when it goes through, probably for debugging type reasons, you say, did it, I didn't do it, I did do it, and then you get the full trace of everything that happened. But that's not what we want on every bundle.
Right,
so,
absolutely.
So I guess, yeah, okay. I would advocate we remove it.
Okay, so I'm going to suggest here that the sense of those of us at the meeting is we remove this flag altogether and make the entire issue go away thereby. And somebody who wants to can suggest, can propose in an internet draft an extension block that does more.
Rick Taylor again. I have a problem with doing that. If it becomes critical for some processing using this future extension block, i.e. not a core flag, and somebody along the hops doesn't understand about that extension block, I can see you getting into some sort of self-perpetuating problem of, well, someone hasn't processed it, therefore I don't know they haven't processed it, because the block they haven't processed is the one that I used to tell me that they haven't processed it.
Yeah, but I think that we have as good a chance of resolving that as we do of resolving what to do with a single bit flag.
Okay, so yeah, let's keep it simple, drop it out then. If you're happy with that, I bow to your superior knowledge.
I think it'd be a good thing to remove and make the whole thing go away. And let's deal with it with an extension block if we really need to. If somebody really cares about that. Any
So Scott,
energetic dissent?
the only thing I would say is that if nobody can stand up and say we're using it, then what you're proposing makes perfect sense.
Okay. I hadn't thought of that until we were in the meeting just now, and I think it's the best resolution. So I'm totally for that. Okay. The next one, the extended class of service features. What the draft has got in it now is I think a subset of the features that are in the extended class of service internet draft from a couple of years ago. The ones that I thought were likely to be the most useful. The question is that the right thing to do? Because what RFC 5050 has as the class of service is essentially a thing that can be, but doesn't have to be, treated as a priority that has 4 possible values. And then there are other fields that we're not talking about removing or doing anything with. like the custody transfer requested flag and that sort of thing. But the class of service is a 2-bit numeric value. The things that are in the draft, as I recall, are extending that field to be to have a maximum value. Well, I think it's 7 bits, right? So the maximum value of 127. So there are 127 levels, and they are explicitly identified as priorities. And then there's option. The extended class of service block also has an option for a flow label, and it has has flags for requesting that the bundle be treated as critical, and for requesting specific types of convergence layers be used for transmission. So all of those features, I believe the flow label is not included in the current draft. That the expectation is that there would be an extension block for the flow label. The other flags, I think, are in the draft, and so the floor is open to people who want to say yes or no on those.
Rick Taylor again. I would say drop these flags. This is all extension blocks.
Okay.
Defined elsewhere. It's a big topic to cram into 4 bits, as I think you've got it. And as you said, there's already extension blocks either in this document. There's some in this document, and some is being worked on external to this document. So yeah, just push it out.
Okay, so with regard to the current class of service, which is the 2-bit 4-value field, you're saying lose it altogether? Okay.
The opposite, Ron and Veld. In the EDA midnet project, we do have a use for this. We want to have the possibility to differentiate between different traffic streams and give them different priorities. So I would want to hang on to the equals feature.
Would it be okay for your purposes for the equals features to be in an extension block rather than in the primary block?
Yes, I think so. Yes, because
okay.
It gives us the possibility to have even more values. We have been experimenting with a thing we call retention classes. So those do not rule the forwarding per se, but if memory gets tight, they decide which bundles get dropped first.
So if I were to restate this a little bit, would you be okay with removing the current 2-bit class of service and instead defining an extended class of service extension block and maybe setting up a little ad hoc group within the working group to get that right, and using that instead?
Yeah, I think that's reasonable. Yeah.
Okay.
Kevin Fall, agree with Rick. Agree with what you just said. One small comment, maybe, if such an ad hoc group, whatever, thinks about this, that we also have in that discussion, what's happened in IP protocols for DSCPs and that sort of stuff.
Okay.
So that we potentially remain compatible. So in particular with the draft as it is now, though, I believe flow labels are there now in the draft.
Well, there is mention of a flow label extension block in the draft.
Right. So
the flow label is not in the primary block.
Correct. But that would be excised then.
Right? Yes, we can just do it in the extended class of service block instead. Sure.
And then the other sort of, in so doing, the critical flag as proposed appeared to really just say mandate flooding as the routing protocol.
No, it's not flooding because it doesn't go everywhere in the network. It's take every possible route to the destination. which is quite different from flooding.
Because then it implies you have knowledge.
Yeah.
But if your knowledge is limited to 0, then you would have to flood, correct?
Well, it's intended for when you do have knowledge, right? It's intended to go with contact graph routing.
So this is overcome by the previous decision, but I think that specifying that it basically has that semantic might be troublesome in certain kinds of networks.
So we might end up with a class of service extension block that has a number of options, and we need to craft that kind of carefully to make sure it doesn't break the network. I think everybody's fine with that.
John Durdle here, just a comment. In many terrestrial networks, they have different ideas of disk served markings as you move from network to network. So if the flow label is in an extension block, that means you don't have to worry about changing the primary block as you're moving around.
That's right. The primary block wouldn't change. Yeah, that's an advantage, and moving it out of the primary block simplifies the primary block a little bit.
I'm trying to remember the use cases that were discussed a while ago about ECOS, and I'm not sure, but there was some discussion within space agencies about, kind of my traffic is more important than yours, or for resource constraints, issues. So the point I'm trying to make here is this. Do we need this in a base protocol that would be used, in different places which are not related necessarily to space as the original, main intent, or therefore would point into extension? While if this is kind of common, then maybe we should put it in the base spec. So I think that could be one way to differentiate if we put more in the base spec or not. And I don't remember all the use cases that we discussed a while ago.
The use cases for the ECOS block in particular were pretty much all space related. So I think that's got to inform the conversation if we work on an ECOS extension block RFC. I'd like to make a point that there sort of are there's the base specification, which is not necessarily limited to the primary block. There are some extension blocks that I think of as being in the base specification, not because they're like optional, but because they are mutable as the block moves through the bundle, through the path, through the network. And so in order to keep the primary block immutable, which I think it has value, things like the previous hop node and the current custodian, if there's a custodian, those kinds of things are part of the base specification but are not in the primary block. So I just want us to keep that distinction in mind when you talk about this feature not being part of the core specification. I think that's where we are ending up, and it would end up as an extension block for that reason.
Okay.
Mark again. Yeah, I should be more precise in my comments saying what must be implemented.
Yes.
That's the core of my...
Yeah, we're on the same page there.
I got Java question from Jeremy Pierce-Mayer. He says, so the proposal is this: take out the current costs and ECOS becomes COS. So I think he's just trying to get a summary here. The proposal is to remove the flags and to point the reader at the extended class of service extension block.
Yeah, that is correct.
Because he goes on to say he uses ECOS for video streaming. He really likes it.
Right.
So,
I think ECOS is extremely valuable. That doesn't mean it has to be in the primary block. And so if there are use cases where those features, some or all of those features are not needed, it makes tons of sense to retain it in an extension block, and let's go ahead and define that. That summary, just to sum up that summary, my understanding of the sense of the meeting is that we will remove the current class of service, which is a 2-bit field, which we don't really know how to use very much anyway. We will make an effort, and it'd be ideal if we could add this to the charter, but I mean, we have to recharter to do this. We will have an initiative to generate a separate RFC for the class of service, and we won't call it extended class of service because it's not extended from anything. It'll be a class of service extension block, and a number of us will have avid interest in specifying that for the various use cases we need to support. Kevin.
Kevin, Paul, concur? Just because we were talking about management of the group questions, now that the draft is sort of doesn't describe the packet format encoding or the message, do we have to do something special to say now there's an activity to define the base sets of those or something?
I think we did that in the conference call. We said that there needed to be additional drafts.
So the charter is good, or will
I don't know.
Will become good.
The charter is another question. Yeah. Do the chairs want to address that question?
We should have a complete spec. So that's.
So it's okay to within the current charter, it's okay to produce those documents. I think that's the right answer. That's great. Okay, good.
I mean, we should not, focus on, 1, 2, 3, 4, 5 documents. I mean, it's the complete spec, right?
Perfect.
Ron Infeld, slightly more general remark. There seems to be a tendency to shove all kinds of stuff into extension blocks, and because the primary block should be immutable and cannot be changed along the way, but I don't really understand why it's so all important to make the primary block immutable, but it's fair game to change extension blocks along the way, because they can also be abused in somehow.
Good question. And I remember we talked about immutability of the primary block on some earlier occasions, and the rationale for that doesn't leap to mind. But I think part of it was the concept that you really want the destination to know exactly what the primary block looked like when it was at origination, so that it could have confidence that the information was correct. And if it could change, then if you had a CRC on it, then that could change as well. That was fundamental information that needed not to change from one end to the next. But if somebody else has opposing views on that, let's hear them.
Yeah, John Dowdle, I could just see Ed twitching. Yeah, I think it was to do with the end-to-end security and hop-by-hop security. So the primary block, that stays the same end-to-end. But I'm sure Ed will confirm that.
Hi, this is Ed. I would like to confirm that. So for every other extension block, we have the option to put an integrity signature on it, so that at some point you can say from the point that it was signed to the point that it was received, it has not undergone modification. If we have an immutable primary block, we're able to have that same service. And there are cases where it is very important to have that. Now, in the original spec, when we had immutable primary block, we had to create a canonical form of the primary block to just integrity sign certain portions of that. And the observation there was that the engineering required to deal with that canonical form was largely unnecessary if the mutable parts of the primary block could be pulled out. So I think that we could exist with a mutable primary block, but in doing so, we're adding needless complexity into the system, especially around things like integrity signatures.
And actually, just to amplify that a little bit, I think we were also thinking about implementation of bundle protocol in firmware and hardware.
Exactly.
And, yes, and that is somewhat easier if you don't have a mutable primary block.
Mark, I was going to say security, silicon, and simpler implementation, therefore forwarding, easier forwarding and fast. So.
It's Rick Taylor here. I mean, the corollary to this is all the trouble we're having with IPv6 header options, changing what's basically in IPv4 a fixed block of bytes. Keeping having one part of your bundle being immutable from end to end has an enormous number of advantages.
Oh, okay, I agree with that.
Ron Infeld, I don't agree, because if the price is to shift all sorts of useful functionality out of the primary block and then in some extension block which you cannot protect because it changes on each hop.
But I disagree with that though, because you can protect the extension blocks with security blocks, and with the way the bundle security protocol is being re-engineered, you can attach an integrity block to any of the extension blocks and guarantee that it didn't change. Ed, is that correct? Would you comment on that?
Sure. So that is true. We have the ability in the new BSP to apply integrity to individual extension blocks. If we take something out of the primary block and move it into an extension block, we can apply security to it as we need to without inventing an additional engineering mechanism. If we have a mutable primary block, then we have to have a second mechanism to protect just the immutable portions, and we get into block surgery of some kind. And I think a more elegant engineering solution to that is to pull it out and use the existing extension block scoped mechanism.
Okay.
But I don't think we lose functionality from that. I think we just don't have to have an additional algorithm to handle a special case.
I agree with that.
Rick Taylor here. Have we got in a terminology crisis here? Are these what we've been calling extension blocks? Are they actually just mutable blocks that may or may not exist, as compared to the immutable primary block? Would that make everyone feel much more comfortable about this? I'm not proposing we actually rename them, but if you consider the extension blocks are the immutable bit that goes along with your bundle.
The naming of these things so that people are comfortable with them has been a problem for a long, long time. The extension blocks there's been this perception that extension blocks are second-class citizens in the structure of the bundle, and I don't know what to do to dispel that notion. It is absolutely not true. Extension blocks are absolutely mandatory for a lot of purposes. They're just as important as the payload block and the primary block. There's nothing second class about them. It's important for people to get comfortable with this idea.
It's Kevin Fall again. So I don't know if they're second or first class citizens, but not every bundle's got to have them, right? Only in certain cases are they necessary to be present. So if you had to say to somebody in the hall, what are they? Well, would you concur that there are things that don't necessarily need to be there in all cases? Whereas it's mandated, you have to have a primary block, and I believe it says block too.
Yeah, that's true.
So although this point is just about true also, if the hallway conversation was, oh, those are the immutable ones or the mutable ones, that seems like it would open up a lot more questions.
So I think that what I would say here is that there are features of the bundle protocol that are mandatory and minimal, and they are represented in the primary block and the payload block. And there are features of the protocol that are non-mandatory, and they are represented in the extension blocks. And if a feature is not mandatory, it has no business being in the primary block.
So there's mandatory implemented and mandatory utilized. Right. So a conforming implementation must know how to process something, and like we have had in the past in IP, the host requirements RFC or the whatever requirements RFC, it lists all the junk you got to do and maybe the stuff you don't have to do. I would imagine we wind up with something like that down the road, assuming it goes forward, right?
Yeah, that's probably right. Any other thoughts on this? Yes, we have one.
Mark speaking. We're kind of diverted a bit the conversation from ecos, right? So can we come back to the resolution of this?
Good idea. Okay. So the sense of the meeting that I am picking out of this is that we will remove the 2-bit class of service field from the primary block, and we will develop a class of service extension block that addresses all the use cases that are important to the user community. Anybody strongly object to that? Okay, let's go on to the next one. DTN times in status reports. This was something that I saw this high resolution time value in the status reports occurring multiple times, I think, and thought, who needs this and what good is it? Let's just take it out. And when I did that, I heard from Carlo Caini at University of Bologna, oh no, don't take that out because that's what we use to instrument the network for DTN perf. So, okay. So I said, fair enough, but not everybody is DTN perf, and these things are quite big, and they're not necessarily useful for all purposes. How about if we make them optional? And he was fine with that. What do we all think about this question? And again, the DTN time that we're talking about here is it's seconds and nanoseconds, so it's a fairly long number, and it shows up in the bundle status reports as the time of occurrence of the event that the bundle status report is documenting.
Rick Taylor again. So Scott, you're saying that you could see no reason to keep the DTN times in status reports apart from used for network management and monitoring.
Yeah, network, I think of it as instrumentation, but yeah.
Sorry, instrumentation.
Yeah.
So and this is a question, does that mean that really the DTN time should probably be pushed into some sort of instrumentation report in its whole own way rather than...
Go ahead.
The follow-on is that if you then make it optional in status reports, are you then breaking instrumentation that expects them to be there? And how does the instrumentation work when they're optional?
So I think the answer there is that the status reports themselves are instrumentation.
Okay.
And so this is a feature of the instrumentation that some users of the status reports will require. They would really like to know, you know, the exact nanosecond on the node that is reporting the status.
So it sounds to me like you've just argued for them to be mandatory then.
Well, except that they're not all users will need them, and so that's why I would like to make them optional in the status report block, the status report records themselves.
Jefferson Nob speaking. I work with a measurement protocol for DTN, and I think that it could be moved for an optional block. At least in my implementation, probably will not be that difficult to move it.
Okay. Anybody else have any thoughts on this? Well, okay, so we can revisit this if people have second thoughts later on, but right now my sense is in the next edition of the spec, I will do something about including these high precision times in the status blocks, but only optionally, and some flag to turn that option on would be present in the bundle along with the requests for the status reports themselves.
Sorry, Rick Taylor again. I seem to remember a discussion a while back about trying to remove the number of high precision timers that are required, which points again in the direction of optional. I just thought I'd chip in before we leave too many of the timers in there.
Okay. Anybody have any strong objection to that general direction? Okay. Well, the last bullet on this slide, and then we have just one more slide to go. In the bundle protocol specification, there's a section that talks about controlling or determining the time at which a bundle is forwarded to the node, and the question came up about the language that's used to characterize that, whether the determination of the moment at which a bundle is supposed to go out the horn if it's being radiated is to be determined by the bundle protocol agent or by the convergence layer adapter. I come down on the side of pushing as much as possible into the convergence layer adapter, but there are alternative possible views.
Kevin Fall, this is one of the items I did highlight independently from your list. I feel generally the other way, particularly in LPI, LPD type of environments, places where it matters.
Could you say that again? I'm sorry.
In environments where you want low probability of detection or interception, it becomes really important to know when you're going to send something. When you have scheduled connectivity that is not on a particular CLA but across multiple. These are all decisions that would be made at the bundle router layer thing and not in the convergence layer adapter.
Okay.
Jörg, I tend to agree with Kevin on that. I would also like to highlight that this is actually probably this decision happens at both, right? Because you have.
Can you say that again, please?
You do have at both. You do have the decision when you're going to hand off something to the adapter layer, and that may be a higher level decision, as Kevin just pointed out. And then for a given convergence layer, you're going to have maybe a local queue. Maybe you are going to have some medium access control that you need to adhere to. Maybe you have some transmissions that need to finish before you can do something. You may have some interleaving decisions, and that's going to be taken at the convergence layer. So I don't think there's an either or.
I completely agree with that. I think that's the right answer.
Naglash, I was going to say the exact same thing. And I would like to add that in the BP spec, it should say BP, right? It's up to the convergence layer that, may decide various things, therefore both. But in the BP spec, it should say BP decides.
Okay, so
do you understand?
Right. But I think the way I harmonize that with the other remark is that in the BP spec we can say that the bundle protocol agent decides exactly when to present the bundle to the convergence layer for transmission, because it's got control over that, and it doesn't have any control over what the convergence layer then does. Yeah.
Rick Taylor here. I'm agreeing actually with everyone here that actually the decisions are made in both places, and my suggestion might be some verbiage in there to say that the bundle protocol decides when to place a bundle into its effectively out queue. This is now ready for the convergence layer to distribute, and then the convergence layer can do whatever intelligence it requires at that point. And some sort of words like that might put the level of clarity in that you're trying to achieve, to say bundle protocol makes some decisions about when it is going to transmit. But of course, the convergence layer can decide to ignore that entirely. But some queue, you're ready to send state or something like that might be the way to get around it.
We already have the language about presenting the bundle something like presenting the
Yeah.
bundle to the convergence layer, whether that's a queue or whatever. And I think that's I think that's the
I
right
think
way
that's
to
the way
say
to go.
it. The bundle protocol agent can determine absolutely at this moment, I will hand this to the convergence layer adapter
Yeah.
for transmission. And what it does then is up to what it does.
Right, Kevin Fall, concur with all that. Just was thinking as I was reading this bit that the way I would implement this, I think, would be that the bundle layer would give a requested transmission moment to the CLA, which would then make some decision about whatever its queuing is and its scheduling is, and then would report back when it best thought that it was sent. Hey, I think it went out now.
Mm-hmm.
I have a statement from Jabra. It's a sort of question from Raphael. I'm afraid I can't pronounce your surname. In my opinion, forwarding packets must be performed by BPA because the convergence layer is dependent from transport layer. In case of failure, the BPA has the time information necessary to restart the transmission. I think he's kind of agreeing that.
Yeah, I think so too. I think that's consistent with what everybody's saying. So Ed, yeah.
I did just want to make one additional comment. This is Ed, to Kevin's point where you want to strictly control when you are radiating. The BPA should be able to put something into the outqueue saying, I think it should go now. And the CLA can, in concurrence, decide when it does it. And if that decision adds plus or minus a few nanoseconds or milliseconds or maybe even seconds, that's okay. If the CLA does something grossly inappropriate, that's not okay. When we define a BPA to CLA API, do we need something in there that says this is when I think it should be emitted plus or minus some error margin? So if a CLA says I will take that time, but I'm not going to transmit this for another 10 minutes, is there some way of saying no, that's not appropriate? Do we need that mechanism?
Well, so let me just remark here that we can describe that mechanism, but it's not a matter of interoperability, right? So it doesn't really have anything to do with the protocol specification.
So correct. I guess the question there is when the BPA passes off to the CLA, this is when I intend for you to transmit. From a specification point of view, we don't need to put any quantify any assumptions around that.
Okay. Yeah, my preference would be to leave that to the implementation.
Okay.
With maybe a
Rick Taylor,
maybe a remark that says it's advisable to do something like that. I don't know.
Rick Taylor, as a follow-up to Kevin and Ed's point, is you're describing CLAs with really strict time boundaries. I have CLAs which work in a pull model. So the bundle processing agent says these are ready to go. And in highly dynamic man-made style networks, then there's no way the bundle protocol can know, and it's down to individual CLAs to start grabbing things opportunistically. So
and
you can't specify it.
That's true of all the spaceflight use cases. The convergence layer is what decides when it's going to go. Not bundle protocol is not going to do it. So I think the way to address this is to beef up the language and say, here's what the bundle protocol agent does. It presents the bundle to the convergence layer adapter at a time of its own choosing, and we can add a note or something that says, for some use cases, it may be necessary for the or maybe advisable anyway for the bundle protocol agent to constrain the time at which the convergence layer adapter does it.
Rick Taylor again, Scott, I wouldn't bother putting those extra notes. I would say the bundle protocol agent decides at what point it presents it to the convergence layer. What the convergence layer does with it is an implementation issue. And it's out of scope for the document.
Okay.
Otherwise, I think you're going to get caught up in 6 or 8 paragraphs of could be this, could be that, and then someone else will raise a different use case. I wouldn't go there personally.
Okay, I'm fine with that. Anybody strongly object to that?
Kevin Fall again. I don't object, but just to summarize everything he said down, it does highlight that what the wording would say is that the job of the agent is to decide not only what CLA or CLAs are used, but when they are used.
That's fine. Sure. Yeah, absolutely. That's and I think the spec does not say that now, so that's a good important thing to update. Anybody have anything else on this topic? Next page. Look at this. Last page of open items. Okay, this is an item on, and is Ellen here? I didn't see him. Ellen was the champion for this concept of a list of what the blocks were when the bundle was sent, so that the receiving node can tell whether something was removed. The current spec has got some language in it for listing all of the types of extension blocks that are included in the bundle at the moment it's transmitted. I really wanted Ellen to comment on whether or not that meets his requirements. Does anybody else recognize the same kinds of requirements and have any comment on whether or not the mechanism that is currently in the spec does the job?
Rick Taylor, is this a question for Ed and the security protocol, really? Because it sounds to me the reasoning for the inventory management is to look at tampering or alteration along the path end to end. Does this really become a maybe quite a soft security issue, but is this it's an open question.
So this is Ed. Not entirely. If we have processing flags that say something like, if you don't understand the extension block, drop the extension block. You could get to a point where something at a destination, even in a deployment without any security, arrives with less or more or different extension blocks than were originally put in. The question then becomes, does the destination care about that? And the destination might, depending on the implementation, say, I give some level of priority to the things that were part of the source node, and things that sort of accumulated along the way I care less about. So that is, short of putting a source stamp on every extension block, which I am not advocating for, it would be tricky to do that. My question on the inventory block, which maybe gets to a different question, and maybe it gets to the next point, is what you represent in the inventory is going to be based on what is necessary to uniquely identify an extension block. And is that only block type, or is that something else?
And that's exactly why in this latest edition of the draft, I didn't even try. I just said, here are the types of extension blocks that were present at the time of transmission, not what blocks there were, because I didn't see a good way of doing that. But Rick.
Yeah, Rick Taylor again. This is why I pointed the question at Ed, because I was starting to think through this, going, oh, well, do you want the type? Do you want to record the length? Do you want a CRC, or should we put a cryptographic hash on that? And oh, cryptographic hashes. Oh, are we now starting to get into signing and checking for tampering? Oh, this is a security thing. That was why I turned it into a security question. Oh, I don't have an answer. It seems like a sensible thing to have, but does it play into I'm starting to put on security in terms of I want to know what's happened to my bundle? Sorry, a completely open question, open statement to the microphone.
So if I channel Elwin for a moment,
yes,
and I think in addition to everything you say, which I agree with, is there utility in understanding that an extension block was lost along the way? Now that's not necessarily a security. It can be, but it's not necessarily a security issue. In the same way of, do we care or not about whether an extension block was forwarded without being processed? Is there a useful reaction to understanding that? It seems to me that the only value of an inventory, separate from individual integrity, is to understand whether an extension block added by a source node didn't make it to the destination, and do we care about that?
And my sense is that Ellen says he does. And does anybody else recognize this requirement? Anybody else running into this as a problem?
It's Rick Taylor again. I can understand the need for it as an optional mechanism. I can understand you could have an entirely closed-in DTN, as private, where you don't care. You've got trusted nodes throughout the network. Who cares? To strip that off and make best use of my bandwidth. But equally, I can totally understand the reason for it when you're crossing across an interconnected, heterogeneous DTN system. And then by making it optional, are you starting to classify it in terms of, oh, well, this is a network management and monitoring solution, so I want to know if my flow spec is being stripped off as I cross between DTN domains? I mean, do I disagree with your flow specs? Am I just throwing them all away because I don't like yours? And that becomes the whole, is this now DTN network management, and should it be addressed there, or should it be addressed as part of a security piece, or should it be addressed as part of the core bundle protocol? And I'm just asking questions again. I don't have the answers for this.
So it's possible that we should just punt this question for at least until the next conference call, or for the next edition of the protocol spec.
John Dowdle. Yeah, I think I'd be in favor of making it optional as well. If it's something that you cared about in your network, put it in. But I guess it would itself have to be an extension, because your inventory will change as you truck along through the network.
Well,
how many blocks?
I think the way it was written up in the current draft is that it's optional, but it's in the primary block. You have an array of block types, just the types, in the primary block, and that array may be of 0 length if you decide you don't want it. But because the primary block is immutable, it's there for the duration.
Rick Taylor again. Is this an example of actually a immutable extension block?
I think of it as being an immutable option. Yeah. That will go into the immutable part of the bundle, which is the primary header. Primary block.
So, sorry, this is Ed again. Something that came up when we were looking at some of the firmware accelerations for BP was the need to not have to process the entire bundle before we understand where certain extension blocks live in the bundle. And Greg Menke, we had talked about some sort of a index or a table of contents for a bundle, which could be added in from the inventory standpoint. So there may be utility not as part of the base spec, but the reason I bring it up is if we do carry forward the idea of inventory, there are at least 2 inventories that I can think of. The first is the list of things as integrity signed by the source bundle as the source node for the bundle. The second is the table of contents listing bit offsets or byte offsets into the bundle, so that hardware acceleration could jump to where it needs to. I want to make sure we don't confuse those 2 concepts when we talk through it, and perhaps inventory should be changed to something else to prevent that confusion.
Yeah, sure. I'm always happy to fiddle with the name of something as opposed to doing something substantial, which is much more dangerous. Why don't we table this for now, because I don't think we've got an answer, and we don't really have a firm statement of what the requirements are. So rather than agree right now to just remove it, let's just agree to think about it between now and the next time the draft comes out. And if we have an interim conference call and take it up then, I think it'd be good to do that. Okay, so that leads us to the next one, which is actually quite closely related, except...
Sorry, Rick Taylor again. Can I totally agree, this is one of those take it to the list things, but could I ask somebody, either a chair or Scott, to kick off a summary question, just to kick off that discussion?
On the mailing list, absolutely, yeah. So related to this actually is the next point, which is a radical idea, and it came out of looking at the way the bundle security spec bundle, the block integrity block and block confidentiality blocks were being implemented in the BSP spec. There is this sort of general issue of a block referencing another block, and exactly how do you do that? And related to that is the question of the inventory. If you've got 3 block integrity blocks, well, you definitely have blocks of type block integrity block, but what are they and what do they refer to, and how do you know if one of them was removed? How do you know which one? And it seemed to me that a solution to that would be just to say, oh, well, let's just get rid of the multiplicity of extension blocks and say, if you've got an extension XYZ, there is a block for extension XYZ. And if there is a multiplicity innate in the information for that extension, encapsulate that multiplicity inside that block, so that if you're doing an inventory and you want to say the bundle started off with a class of service block, you don't have to. It's a bad choice because there's not multiplicity anyway. But if you want to say that the bundle started off with block integrity blocks, there's just a single block integrity block extension. All of the block integrity signing would be multiplicity inside that block integrity block, and if that was removed, the whole thing would be removed. And that's the granularity of block removal. In some ways, I think this simplifies things. Ed pointed out that in some ways it doesn't, because now the bibs need to refer to individual multiplicity items inside of the blocks. So maybe it's just not worth doing. And I'm happy to back off on that, but I thought we'd at least talk about it a little bit here.
Rick Taylor again. I'm in favor of keeping the multiplicity in there and having some concept of an instance ID. So this is the 3rd instance of that type. It just seems much simpler. The main reason for is if you're actually removing one of these instances of a block, if you have to take apart the inside of take a small chunk out of an existing block, you have to shuffle that block down and then shuffle everything else around because it's got smaller, rather than just dumping the block out. I don't know about the security, but I get the feeling it makes the individual signatures a bit more complicated along the way. We know about types and instances. Let's just do that.
Okay.
Jörg, I have a similar feeling that it would be easier if we just keep that explicit at the outer layer and have individual in terms of processing, removing things, adding things, also not tampering, tampering with protection that may have been applied to a block that's already present.
Mm-hmm.
So then that would at least allow some whatever block-specific integrity protection if you wanted to have multiple things added of a certain kind. I don't know which precise blocks you had in mind, but if that should be a general concept, then I would be in favor of allowing multiple instances.
Okay. Yeah. So that sounds fine. And so I think the sense of the room is to retain the extension block multiplicity the way it is now, and just have a identifying number on the extension block in addition to the block type, which I think is already in the spec. That brings us to the last 2 things here. The last one, I think we don't need to talk about now. That definitely, I believe, needs to be handled on the list. We need to pick out some specific CRCs we're prepared to support, and let's not try to do that here. And so the last thing that that I'd like to resolve before going off and doing the next edition of the spec is this question relating to what transmission and what forwarding refer to. But Kevin, please.
Kevin Fall, chair of DTNRG, co-chair. I propose that be a DTNRG question. And for what it's worth, some previous work has been more of the second of the two options.
Oh, which I agree with. Yeah, I think that's absolutely the way to do it. Yeah. Okay. Yeah. Jörg?
Agree. A related question would be whether that the research group could deal with is whether such a retransmission or forwarding or whatever would actually, if you looked into the information-centric model, whether there would actually have to be a source address.
Can you say that again?
The origin doesn't suddenly matter anymore.
Oh yeah, right.
So there's more fundamental things to be discussed in that context.
So we're not going to. So I would suggest that the resolution on this point is that I believe the language that's in the spec now defines bundle transmission and bundle forwarding in a way that is consistent with what Kevin was just saying, and the way I think if we used DTN for ICN, the way it ought to work. So I will propose that the resolution here is not to make changes to the bundle protocol spec, and to commend to the DTN research group that it investigate potential for using DTN for information-centric networking. Kevin.
Kevin Fall again. So this one I didn't put in my comments, but it did, because I thought it might make everyone's head explode a little too much, but I'll just throw it out there. So the way the spec is now, when it talks about fragmentation, it talks about extents, a certain amount of the bundle, the rest of the bundle, and so on. If and when we ever get to the point where those things are erasure coded or they're in some other format that doesn't lend themselves to extents of that kind, that may frustrate the way that the fragmentation is defined right now.
So do you have a proposal to
Well,
change?
I don't quite. I didn't know. That's why I didn't actually write it down. But I was thinking, what words would I use that were not the first n bytes followed by the rest? But it seemed like it opened up so many can of worms that it just said, why don't we just get this done without that complication? But I just thought I'd throw it out there for people to think about that.
I will suggest that that's another excellent topic for the DTN research group. So does anybody have any objections to this last proposal for resolving this last item? Any going once, going twice? Okay, thank you very much. We've gotten through the entire list. I'll try to get another edition of the draft out in about a month and a half, 2 months. Thank you.
All right, so we didn't eat the entire time there. We'll have Ed come up and talk about the security protocols.
I'm in the box. Stay in the box. Okay, so DTN SBSP 01 is a somewhat minor revision to DTN SBSP 00. Oh, thank you. And I wanted to talk through some of that, what some of the small changes were, and then we have a list of open questions, and perhaps in a similar way to what Scott was proposing, we could get a sense for the room to see what it is we would want to change going forward, and then ask the question whether this is the draft we want to adopt within the DTN-WG, so that we could give it a name other than draft Bahrain DTN. And I don't know how to use a clicker. Which button?
I'll do it.
Is that not, do I need that one?
No, I did it.
Oh, thank you. I'll just keep this. So one of the major changes to the SBSP 01 was that we wanted to capture what we felt were the key properties around the security model associated with this. And the reason that that came about was, as we got into some of the other changes referring to the cryptographic message syntax and how we wanted some of the integrity blocks and confidentiality blocks to interact, there were a lot of questions that said, well, what are the driving requirements for security in DTN? The answer was many of those driving requirements are going to be network specific and implementation specific, but could we put something together as key properties or desirable properties or guiding principles that said this is what is it valuable to us at a high level and at a universal level for security. So we came up with some of those. The fundamental ones are we want end-to-end services, right? We want end-to-end confidentiality, end-to-end integrity, and we want the ability to pick our cipher suites based on the kind of network that we have. And then we've added these other ones as the key properties. And then I have slides for each of these going next. So if we go to the next slide. Block level granularity, having put aside the block multiplicity question so that we don't have sub-block level granularity. One of the things that is important in the security suite is that a security service, and in the spec we define a security service as authentication, integrity, or confidentiality, it can be applied to an individual block as opposed to the entire bundle. So we can get into situations where, for example, the payload is encrypted, but an extension block is perhaps integrity signed and not encrypted, or encrypted with a different key than the payload, that the users do have that option to treat extension blocks differently from a security standpoint. Multiple security sources goes with that. It is sometimes the case where the source of a bundle will understand all of the security mechanisms that have to be applied to the bundle, and it can be sent to its destination. There are other cases where a waypoint node, based on a routing decision or a policy decision, may want to add, not remove, but add security services to the node before it goes on its way. A simple example of that is if you are routing network within a local trusted network, perhaps you only integrity sign some of your information. Perhaps if that bundle gets to a gateway node and is going to go somewhere else, you would like to add a confidentiality service as well. So perhaps within some enclave, your payload is integrity signed, and perhaps when it goes somewhere else, it's encrypted. And maybe you make that determination when you originate the bundle, and maybe you make that determination at the point of forward into the other unknown or suspicious enclave. So we want to have situations where something other than the source node is able to apply a security service, so long as that security service is not in disagreement with the security services that are already there. And none of that language has changed in the spec. Third, and this has become a very important one, is that we want to maintain a single security destination. So if a security service is the point in time when we add an integrity signature or when we add ciphertext, the security destination is the user who will ultimately be verifying that signature or decrypting that ciphertext to get the plain text back. In the original RFC 6257, there was a concept of multiple security destinations that would come back and say it was possible, for example, for an extension block to have a different security source, meaning someone else applied a security service to it, and a different security destination, meaning some waypoint node in the network would be the ultimate consumer of that block from a security standpoint, separate from the consumer of the bundle. What we found in implementation was that this coupled the security plane and the routing plane. And how could you ever select a security destination separate from a bundle destination unless you knew the path that the bundle was going to take through the network. And in some cases you do, and in some cases you don't. So for the cases that you do, there are other ways around that. And for the cases that you don't, you're in a situation where something might not be implementable. So what we recommend in this security spec is that all security destinations are the bundle destination. All security services terminate with the bundle. If you run into a situation where you need a security service that is only applied to a portion of the path, then there are other mechanisms for accomplishing that. The one that stands out the most is some sort of tunneling, for example, using BIB, bundle and bundle encapsulation, and Scott has written up that specification to say, I'm going to take my current bundle and its end-to-end properties and encapsulate it into a different bundle that has a different end-to-end and represents my tunnel. Kevin.
Kevin Fall. Why is that better?
Why is it better? Because you don't tie security to the routing plane. What happens with my encapsulated bundle, if that's how we use it, I come back and say, if I am trying to get my bundle from A to Z, and I want a security destination that is G, and I at node A, or whatever the security source is, have to say, your security destination is G, even though your bundle destination is Z.
Right.
How do I know at the routing level that I need to make sure that whatever route I choose goes through G? There are two ways you can do that. You can presume that you know exactly what path you have, and in some networks you can do that. Or
no, not exactly what path, that there exists a waypoint along the path in an appropriate place.
That you hope that that exists somewhere along the path.
Well, the consequence of it not being there is that it doesn't happen.
Well, right, and or the consequence that you get to Z before you get to G, which is also problematic. So one way of making sure that you don't get into any of those, what I would call edge cases, is you say, I'm going to take the entire bundle, I'm going to package it up, and I will make its destination G. And it will go to G using any routing mechanism available. And when it gets to G, it will unencapsulate, it will do the security processing that's necessary at G, and then from G, it's allowed to continue on its way to Z. And what you've done there without any additional special mechanism is you've made sure that G is going to be visited before Z.
So the whole additional mechanism is the other layer of encapsulation you have to buy off, though, right? We could do this with a loose source route, for example, and get a waypoint along the path, and it would work just as well.
So, which is why we say that tunneling is one of the ways to do this, and I'm sure that it is not the only way to do this, but a mechanism that comes back and says, we want to make sure that we get from one place to another, bundle to bundle, is going to be preferred. My claim is that it is preferred than having individual security destinations for every extension block. The thing we haven't addressed is what happens when you have extension blocks in a bundle that have individual security destinations that are themselves incompatible. For example, because they came from separate security sources. So even assuming that you can draw the path correctly, if you allow separate security destinations, you could still wind up getting yourself in trouble. If we do have single security destinations and we have multiple mechanisms to making sure that we can do tunneling or other kind of loose path routing, we should explore those, but I wouldn't use that as an argument to have separate security destinations.
Okay. There was a whole discussion about this at one point, and it just seems like it never quite bottomed out all the way, but I'm not going to push it further at this point, but it seemed like that was I understand there's the challenges, but there was definitely use cases in which that was presented that would avoid all the extra layer of tunneling that's required ordinarily, right? Basically the cases where you have enclaves at the endpoint, you only have one gateway at the edge, and that's the one sort of case where the security, and that is useful because in the same way that we have firewalls as a thing that was invented, we can hope to secure that separately from the enclave that sits on the other side of it.
So I don't disagree that there are pathological topologies that match into this very well.
What is this, yours or the previous one?
No, the one that you had talked about where you come back and say, well, we have firewalls, we have pooling points.
Yeah.
We know, we have a priori knowledge in our routing plane that we are going to collect at these bottlenecks before we go back out again. And because of that, we can centralize security services at those bottlenecks.
Right, which is what we do all the time, right?
Well, not in like all the DTN places that we're thinking of. but,
Okay,
you know,
I mean,
so-
that may be fair.
So the issue really becomes, we have tied security to a routing plane in that architecture. The question is, do we want to enforce that tie in the protocol specification, or do we want to say that is an interesting and perhaps very popular architecture in some areas, but unimplementable in others? So what do we do about that?
Mark, maybe we should.
Sorry. Yeah. So I guess maybe the recap on that is a desirable property of not having, maybe the better way to say it is, instead of saying single security destinations are bad, maybe the thing that we talk about is the kinds of ambiguities that are brought about by having multiple security destinations have to be prevented before we allow those in the spec, or my recommendation.
So I think that might be right. Have to be prevented. You know, we have to prevent certain kinds of things when we deploy networks too. And so whose job is it to prevent that? Is it the operations of it, or is it the protocol designs problem?
Well, this became, what was it, caveat implementor? So the issue was, how do you realistically put constraints on two different extension blocks that could be mutually exclusive from a security standpoint? And at that point, is it an implementation problem or is it a specification problem? And we treated it as a specification
Right.
problem because for an entire category of deployments, it couldn't be done.
Okay. I mostly wanted to emote that there was a discussion of, you know, that took place for those not participating.
Next slide. So a couple other parts. A mixed security policy meant that different waypoints in the network may have different security policies on how they treat security information. The driving example and the use requirement for this is if you add an integrity signature, for example, onto data in the bundle, you have the option at waypoints to verify that integrity. So why would you want to do that, and why would you not want to do that? You would want to verify integrity early and often to throw bad data out of the network. If you put an integrity signature on your payload, if it fails that, then why are you keeping routing around data which you know is eventually going to be dropped down at the ultimate destination? The flip side of that is maybe you don't have the keys, maybe you don't have the ability to do the integrity signing, or maybe your waypoint node and you don't want to do it for other reasons. So you want to be able to say, as opposed to every waypoint must do integrity verification or no waypoints do integrity verification, we want this to be a policy, you know, a hop-by-hop policy decision. Additionally, there may be non-security nodes that are in the network, and we need to understand those. That becomes a real problem with authentication, and we have that as one of the open questions at the end of the slides. But we don't want to make the strong statement that BSP or SBSP cannot be deployed in a network that is heterogeneous, meaning some BPAs understand security blocks and some BPAs do not understand security blocks. Clearly, if a bundle agent does not understand a security block, it makes it difficult for it to be a security destination, but that doesn't mean that it can't be a waypoint. User-selected cipher suites. Part of that is that cipher suites are changing, and how we want to use them is going to be based on the kind of network and the kind of data. The other part of this was we wanted to break down the organization of the document into three different kinds of or flavors of specification. In the original 6257, we had different kinds of data in one spec, and if something changed, the entire spec had to change. We had the protocol, we had some what I call recipes for how to get security results, and then we had the cipher suites that had to be implemented. What we recommend here is to break off a BSP as only the protocol itself, put together either profiles or personalities or something that deals with different kinds of cipher suites and how they would be applied as a separate document. And then a separate document, a third separate document or third class of document, which are the recipes, how you bring together BibE, SBSP, or BSP cipher suites to get security services for different network deployments as best practice. And then the last part was the deterministic processing. What we found from an implementation point of view was to close the various loopholes and what-if conditions around when integrity and confidentiality is applied and how that interacts with fragmentation as we know it. it made things much easier to lock down some of the rules that say we do not apply security services to individual fragments. If we receive a fragment and we want that fragment to have a security service, we can encapsulate it in some way and thereby make it not a fragment by encapsulating it in another bundle. You get around issues of what happens when you get fragments that come in that have different and perhaps contradictory security services applied to them individually when you do your reassembly. And in general, interactions between confidentiality and integrity in the bundle, we want to get out of situations where we would have perpetual loops, where you could integrity sign a confidentiality result, which itself is protecting someone else's integrity signature, which in turn is signing someone else's confidentiality result. Kevin.
Question. So I'm processing this last one a little bit. So if I select a path and generate fragments, I am going to discover the topology of all of the nodes along the way in a way totally different than if I had non-fragmented traffic, right?
Okay.
Is that true?
I don't know.
I'm concerned about traffic analysis in this suggestion.
So the decision of what makes you want to fragment and how you forward fragments in the network, I claim, is separate from the security discussion.
So you've said fragments don't get security, right? That's
yes.
How is that not related?
Well, so if I have a bundle, because if we look at the different cases, the way that I would answer that question is by looking at a couple different cases. One is if I receive a whole bundle in and I'm choosing to do the fragmentation, that bundle may have security services applied to it already. Perhaps the payload is already ciphertext. If I fragment that bundle and send the fragments on, I don't need to apply additional security to those fragments. I have fragmented ciphertext in that example, and then upon reassembly, they come together. If, however, I come back and I say, I am the fragmenting node, and perhaps I don't have confidentiality, then I want to say, well, fragment 1, fragment 2, fragment 3, I'm going to do one of two things. I could fragment the entire, I could encrypt the bundle and then fragment it, and then the fragments have the security inside of it, or I could fragment first and then apply individual services to the fragment. The difficulty with that is what happens at then a downstream node when I fragment that fragment and I add additional security services to it. And then when the original fragments, the fragments of fragments all come together at the security destination for assembly, do I have the ability at the BPA, and do we want to require the processing at the BPA to say that I have to apply security services to fragments in a particular order to make sure that I reassemble everything appropriately? That is probably technically possible. I don't know that we wanted to recommend it in this spec, and we thought a different and perhaps simpler solution to that, simpler solution from a standard work in all networks way, was if you receive a fragment or you generate a fragment and you decide through some policy, either through traffic analysis or routing analysis, or it's Tuesday, that you want to apply security services to that fragment, you don't apply security services to that fragment. You make that fragment the payload of a bundle that exists solely to capture the security services around that fragment, and then you send it on. And what that helps with is when that encapsulating bundle gets to the destination, the fragment can have the security policy evaluated at the destination as part of extracting the fragment from the encapsulating bundle, and then the reassembly can occur without any prior knowledge that that level of security had happened.
But that policy is now applied by the thing producing the outer wrapped bundle, right? Not by the original sender.
Correct, because the original sender doesn't know that it's going to be fragmented, otherwise the original sender would have done the fragmentation. So if I'm a fragmenting node, I'm creating a fragment, and then I'm creating a tunnel for that fragment if I, the fragmenting node, believe that that fragment needs security.
But if I generate a fragment and you're as the sender, and you're an intermediate node, is there a case in which you receive it and then encapsulate it in bundle encapsulation?
If I am a waypoint node, and I receive a fragment that was generated from others.
Yeah, by me, say.
By you. So you were not the source of the bundle, but you were the fragmenter of the bundle, and I received one of your fragments.
Well, I'm both, let's say.
Or both.
I'm attacking you, basically.
So I can come in and what we have written today is that if I choose to apply a security service to that fragment, I will wrap it in a bundle to send it on to its ultimate
If
destination.
you choose.
If my policy says that when we talked about multiple security sources, we said that waypoints in the network can choose to add additional security services separate from the source of the bundle. So if I receive a fragment and I say, you know what, my policy says anything that goes out from me based on this destination EID has to be integrity signed. And I've received a fragment, I want to integrity sign this fragment. What SBSP would say is don't integrity sign the fragment, do something else to encapsulate it into a bundle and integrity sign the payload in that bundle, which is going on to the destination. Because that gets you into less trouble than integrity signing the fragment as a fragment and then dealing with the additional downstream fragmentation and reassembly issues.
Okay, I'll have to think about that one.
Okay. Next slide. So here is an example. I won't walk through this in great detail. It is pulled from the spec, but it looks at the idea of some of the terminology that we have used. Some of the cipher suites require 2 extension blocks, one pre and one post payload to capture. That may go away if we make the decision. I don't know if we made that decision or not, that the payload block in BP will be the last block in the bundle.
This is Scott Burley. Yeah, we did decide that in the August 28th conference call. So
oh, good.
payload block is the last block in the bundle.
So please ignore all of the blocks that are after the payload block in this. So when we came back and they will all now be lone blocks or individual blocks, we have the idea of a primary block B1. You could have a BAB in the original case, a first BAB B2 and a last BAB B12, which is providing some coverage. You could have a lone bundle integrity block, which is listed as B3, and it provides an operation, integrity on a target. So a security operation is the tuple of a security service and the target. And in the spec, we require that operation be unique in the bundle. So if we come back and say we're applying integrity to the primary block, that's what we have in B3. Then that is the mechanism for integrity on the primary block. We do not allow another bib that also provides integrity on the primary block. That was one of the simplifications in the protocol. We did not want multiple security results pointing to the same target. It clearly fits some of the key properties that we have. All of the security blocks will have the same destination, but they can have different security sources based on who added them. All right, next slide. So then there was someone raised the question of, well, what about the cryptographic message syntax, which is a standard way of representing some of the additional data and wrappings around the keys, the signed data, the signed properties, things of that nature. And so we wanted to address that in the BSP-SBSP. The way that we have done it currently in the spec is to say there were a couple of proposals on the table. One was users could just put CMS in as their payload and not use BSP at all. And that's certainly fine for some cases. We have other cases where users don't use the security services in DTN. They just make the bundle however they want and do application layer security. The other was, could we create a CMS block itself, which has a payload that is the CMS data? And it can target another block. But otherwise, if all I want to deal with is CMS data, I don't need special cipher suite attributes and other attributes that lay it out. I will just put everything in the payload and use CMS syntax. And that's what we've added into the spec. And then if we add a CMS block, what does that do to the rest of the spec? And one of the things that it does is we would make the cipher suite ID and flags associated with the spec now optional, because clearly a CMS block would not use them. It would represent that information in the CMS text that comprises its payload. And then we would update some of the processing rules to enforce the same restrictions that we have now, which is that a security operation remains unique in a bundle, meaning a CMS block could not provide integrity for something that an integrity block was already providing integrity for, or confidentiality. Almost next slide.
Kevin Falk, question for anybody who knows the answer. Does CBOR play nice with CMS?
I do not know the answer.
No idea. Anybody?
So what I can say is that there have been some tests run on how small can you make CMS. Certainly in certain cases where it is mostly ASCII, it can be large, relatively large. There are binary encodings for CMS that get somewhat smaller. None of them are quite as small as what's in the original BIB and BCB. So both the size on the wire and the processing associated are going to be things that will determine who uses this and when.
Okay. I just, whenever that moment comes to discuss the encoding of these things, there's the CBOR people out here and the CMS people, and I don't know to what degree we'll want to draw from them, but I was just wondering if people knew if they're copacetic or not.
Yep. Next slide.
So Kevin, I may be able to find the answer for you because I will be seeing both CMS and CBOR experts sometime this week. So I can ask that question.
So if we were to use CMS blocks, it brings up another question, which is, do blocks eat other blocks?
Sorry, I have a late question off Jabber. I wasn't paying attention. Jeremy Pierce-Mayer says, there isn't a spec for it. CMS is dependent on BER/DER encoding.
Oh, thank you.
That's what he says. I'm getting frowns from the room.
So then the next question there is, do blocks eat other blocks? And what does that mean? If you have a security block that provides encryption of a target block, does that target block is it still allowed to exist in the bundle as the target block? Or do you completely remove the payload and bring it inside of the payload of the confidentiality block as a block level encapsulation? So we have an example here, which was actually written by Jeremy, where we would come out with an example of a lone CMS block, the CMSB block 3, which is providing some level of confidentiality on the payload block and requires the payload block to then have sort of empty data fields because it wants to have all of the ciphertext up in the CMSB itself. That's one of the open questions that is on, I think, the next slide, which is, as a matter of security policy, do we want security blocks to have the option of encapsulating their targets or not? For the BCB, the block confidentiality block, we do not behave in this way. The block confidentiality block would have all of the metadata and additional authenticated data associated with the cipher suites, but it would replace the target's payload with ciphertext. It would not remove the target's payload, and it would not remove the target block. Because removing target blocks also gets into some different cases dealing with inventories and offsets and perhaps fragmentation if that happened at some point. Next slide. So we have a series of open questions, and I've put together what I think are the primary proposals in either direction, and maybe we can get some discussion on them. The first is, do we need authentication at all in the protocol spec? One of the observations was that, and that's proposal 2, we don't need BABs, we have authentication and they're done at the CLA layer, and why do we need this additional complexity at the bundle layer? And proposal 1 says keep them in addition.
Kevin Fall, quick question. When my convergence layer or link layer is a USB key, what happens?
Then it will do whatever authentication a convergence layer as a USB key will do, which is probably none.
Scott Burley. One thing we considered here was convergence layer protocols that did authentication. The authentication is kind of already there. For a convergence layer adapters that don't natively do authentication, we could define a service, a library that is made available to those convergence layer adapters in a standardized sort of way that does essentially what a bundle authentication block does. and is available to make up for convergence layers that don't already have native authentication capability. So that could be something that you could use for the case where your convergence layer is a USB stick.
Rick Taylor, just a quick clarifying question, Ed. An authentication block, that can give you end-to-end authentication? No, it's just hop by hop.
So to define it, the way that in the spec we have defined authentication separate from integrity was that integrity is end-to-end, and authentication is hop to hop.
Right,
So,
but your end-to-end integrity could include authentication. So not only is the payload complete, it also was signed by the person
yes,
you
but
paid it.
in the spec itself, authentication here is, was my last hop sender who I thought it should be.
Sorry, I fell in a terminology trap there.
That never happens with any of the DTN specs.
Go ahead.
Yeah, Fred Temple from Boeing. About the authentication block, I think about the way things work in the internet. Routers in the middle of the network typically don't authenticate packets that are flowing through them. And so is the paradigm the same thing here for DTN?
Well, it depends. You could make the argument that resources in a DTN are typically constrained enough that you want to make sure that you have authentication wherever it needs to be to kick out the traffic most readily. And you could come up with cases where a convergence layer is shared by multiple users. And if one of the users is behaving badly, you want to do something about it at the bundle layer, but you could capture that in the CLA, or you could capture that in a BAB block.
Scott Burley, yeah, that actually was the original rationale for the bundle authentication block, was precisely that the communication links in these networks under some circumstances would be so constrained and so precious that you wouldn't want any possibility of inauthentic data propagating through the network. So you would authenticate the data within the network between adjacent nodes rather than only at the edge of the network.
And one of the issues that came up with that was a authentication is between adjacent bundle nodes that are security aware. And so if we keep BAB in the BSP and it is something that is applied at the individual BPAs, what happens if your route is such that perhaps your destination is not security aware because of a configuration error or something else? There are ways you can handle that. You can set drop the block if it's not understood. You can say drop the bundle if the block is not understood. But that was one of the implementation issues that came up around implementing the BABs.
So Kevin Paul, how does this relate, or does it relate, to integrity protection of the previous hop block?
It's a good question.
So if that has integrity, then you know that, I guess, well, and the demonstration of the integrity is because of a signature that corresponds to the thing that is identified inside, then you de facto have authentication from the last hop, I think, right?
You could do that. You could integrity sign your previous hop and then look at that as an indication as to whether you did the correct overlay hop.
Yeah, so Fred Templin again. So if you have security at the convergence layer or below, do you really need to have authentication at the bundle layer?
Well, that's the question.
Okay.
Yeah.
I think so. I'm not sure.
Rick Taylor, yeah, I think you do. You do. Okay, to try and give you a use case, you've got two DTN clouds, isolated systems, and then you want to make them converge at some point. So you've got two edge DTN forwarders, effectively, from two different autonomous areas. Let's say you want to decouple your multiple available convergence layer adapters that can both talk to each other and let the convergence layer adapters decide which traffic they're going to deliver between these two edge routers. Mm-hmm. You want your two bundle processing agents that exist in two different enterprises to authenticate the bundles that are coming from the other enterprise via any of the CLAs at the bundle layer and say, forget about the CLAs, they could be running across the internet, I don't care. I don't want to build bespoke IPsec tunnels or for every of these possible paths. I just want to authenticate the ingress and egress stuff that's coming through at that layer.
So this is somewhat to your point of you pool convergence layers.
Yeah.
And so integrity from the convergence layers is a less strong statement than integrity or authentication between the two agents themselves.
Yeah. So I'm saying keep them in there because they're useful. I don't say mandate them, but.
Sure, sure.
Magnus, is the, continuing what Scott said, is the authentication up by up really a use case that is for all kinds of deployments or very specific to some deployments? Therefore, do we, that would, to me, change the way I would look at this.
My intuition is that having an authentication block at the bundle layer or an integrity signature on the previous hop block is something that decouples from convergence layers is the most general solution to that problem, because you don't know that you will always have a convergence layer that performs the authentication. We assume that the popular ones today have it, so they will always have it. But to Scott's point, you could also build a convergence layer adapter that gets around a particular deficiency in a convergence layer, such as a USB stick. So I think the real question is a matter of policy and specification. Where do we want to perform this work? Do we want to perform this work in a convergence layer adapter, which either is a pass-through to the convergence layer or applies patches to a convergence layer to perform this? Or do we want to apply it here? The only thing that tips it one way or the other for me is Rick's point, which is that if you're dealing with pooled convergence layers and you don't trust them under the hood, then perhaps you want something else at a higher layer.
Magnus again, and the idea of a simple, implementation kind of a idea. I'm wondering if this should be not, point to point or up by up, sorry, should be handled by the link layer in the way Scott was describing, which is, if you need some authentication and your link layer doesn't, the convergence layer doesn't provide it, then you add a shim to, do it. But then on the BP side, it's more, end to end, because it's more the kind of the network protocol. But
Sure. And I think that is the question we have to
and
answer.
I'm wondering, I'm not sure yet, but I was thinking about, could that actually helps in making, simple implementations, but I'm not sure yet.
Kevin Fall, and then I'm reacting to that with respect to the integrity protection previous hop. So why have the previous hop if we don't normally integrity protect it, or at least if we don't occasionally or often integrity protect it? And is it equivalent to this feature?
So I agree that if we're going to put a previous hop block into a bundle, we should integrity protect that. Because otherwise,
does that make this question moot then?
And if we do that as a matter of policy, could that replace the BAB? I think that it probably could.
Rick Taylor again. Something just occurred to me. You can get rid of the BAB if you do BB, you do your bundle in bundle encapsulation across the one link where you don't have CLA, the pooled links. You can just encapsulate and do end to end, getting rid of the need for a BAB.
Yep.
Scott Burley again. If you have authentication being done by the convergence layer protocols, for example, using TLS, then it seems to me the bundle is being, the authentication of the bundle is being handled by the CLA, and in that event, I don't see why you would need an integrity block check on the previous hop block, because you've authenticated the entire bundle.
So what I'm hearing from this, all of these discussions is there are alternate ways of getting hop by hop authentication, even at the bundle layer without a BAB. So the sense of consensus is, why don't we remove the BAB and talk about hop by hop authentication in a recipe or best practices specification that is separate, that explains these are the myriad of ways that you can get hop by hop authentication using existing mechanisms without creating a new one. If we stop here, because I think we're close to our time, is that true?
Yeah,
we have 6 minutes. But the one question I did want to ask is, what do we need to do to make a decision on whether this is the spec that we want to take forward, and can we rename it just BSP and not streamlined BSP as it is, which is the last slides here. So question one is, can we just start calling this BSP instead of SBSP, or is that going to cause a namespace collision with 6257?
Rick Taylor, why not call it BPSec? It worked for IPsec.
That's fair, if that reduces the confusion.
Mark speaking as an individual, but just in implementations, I'm implementing what, BSP or BSP?
So that's a whole different multiplicity. So if we say, why don't we call it BPSec to avoid confusion?
Well, find a name, but.
And then the other question is, what do we need to do to decide to adopt this or to go with something different?
Well, yeah. How many people have read the spec? I'm not sure.
So I'm going to ask this follow-up question. Those of you who have read the spec, who thinks this is going in the right direction? Thank you. All right, so go ahead.
To have reds on Jabber.
All right, thank you. So in response to Ed's question about workgroup adoption, I think we need to
I'm wondering if we're ready for that. I'm just wondering. Are we all comfortable with that spec, or I'm wondering if people have enough reading to make sure that and
Rick Taylor again. Can I ask the question in response? What happens if we're not ready for working group adoption? Does Ed just keeps working on it and then we'll talk about it in April? And
so I've seen way too many working groups try and expect documents to be perfect before they adopt them, and it drives me nuts. So, I mean, I'd much rather have, and the reason why I asked my question of those of you who have read it, who thinks it's going in the right direction, is a good indication that it's probably close to the point where we can ask that question. So what Mark and I will do is we'll talk about it, and if we think it's ready to do that, we'll do an adoption call in the working group and get it started sooner rather than later.
I mean, Rick Taylor still, from a personal perspective, I understand that it's so closely tied to Scott's work that it's not going to be finished before Scott's work's finished, but that doesn't mean the working group can't adopt it and assist Ed.
Exactly. Right. So Mark and I will have that discussion, and we'll probably we'll make an announcement on the mailing list, and if we think it's ready to make a work group last call or for adoption, we will. All right. We have 75 seconds left. Does anybody have any commentary or questions?
Do people think we should have an interim meeting? Okay. So before the end of this year or in January? January? Okay. We were talking about the virtual interim meeting. Okay. Ah, okay. Okay.
Okay, so if anybody doesn't have anything to follow up, we'll give you 54 seconds. Oh,
Yeah, just to announce that you will get a IP neighborhood, IP neighbor discovery draft very soon, which will be issued as a DTN-RG document, because that's what it was. But I got the green light from the original authors to pick it up, and I'm working on it, and I hope to send it out before this IETF is over.
okay, great. Anything else? All right, thanks for coming, everybody.